So today we're going to learn about graphing and writing cube root functions. Okay, so let's start with the parent function in this case. The parent function in this case is y equals cube root of x. We're going to fill in the table here. Okay, as you can imagine, I'm going to have the easier values here in the y because we're talking about the inverse of the cubic function. So you know that the x's would be -8, -1, 0, 1, and 8. Okay, I know that it's kind of like weird that I'm starting from the y, but I'm thinking about the cubic function. Okay, so I plot my values here, so you know that -8, -2 is here, -1 and -1 is here, 0, 0, 1, 1, and last but not least we have 8, 2, which is over here. So I connect my points here, and that's going to be your parent function. Okay, so as you can see, the domain of the parent function, we do it from the left to the right, and this one is going to be, as usual, all real numbers. Okay, the range is going to be from the very bottom to the top, so the lowest point here is going to be -infinity, and the highest point is going to be +infinity, meaning all real numbers again. As you can see, this graph has an x-intercept, which is the point 0, 0. Okay, and then we have a y-intercept, which is the same, 0, 0. Okay, as you can see, there's a change of behavior. Okay, specifically it's happening here at 0, 0. Okay, so that's the inflection point that we have. Now you can see that the function is increasing or decreasing. Okay, so in this situation, if you always read your graphs from the left to the right, you see that if you take your pencil, it's going up. Okay, so it's increasing. Okay, so you know that your function is increasing in this situation. Okay, so over what interval is concave up? We talked about concavity before, but in case that you don't remember, what we have here is basically, you know that the concavity, as I always say, okay, so concave up is when your cup holds the water, okay, and concave down is when your cup is dropping the water. Okay, so that's concave down. Okay, so as you can see, we have here halfway concave. It would be like concave up, okay, I would say. So you know that it's concave up here, because even though it's not identical, you can hold the water here, so this would be concave up from -infinity to 0. You are never going to include the point of inflection. Okay, then concave down, you're basically dropping the water here. Remember, this is halfway through the cup, so that when you're dropping the water, so it's going to be from 0 to infinity. Okay, so that's for that. Okay, so now a little refresher about transformations. Okay, so remember that the parent function of a cube root function is going to be y equals, and the a is going to be your vertical compression or stretch, depending on the case of your a. Then you have the cube root of b. B is going to have, it has to do with the horizontal compression or stretch. Remember, the one that you're going to evaluate is 1 over v. How does it behave? Then parenthesis x minus c. The c is going to be your horizontal shift, and finally the d is going to be your vertical shift up or down. Okay, please remember always to factor out the b once you have both the x and the horizontal shift. Okay, so the points, if you want a general formula for how the points are affected, is this. Okay, so let's start with the first problem over here. Okay, so if I want to graph the situation, what I'm going to do is I'm going to start reading my equation. Y equals -2, so I have two transformations here already. I'm counting them. Then you have parenthesis x plus 6, another transformation, and this is your last transformation. So officially we had 4 transformations. Okay, so your first transformation is a reflection, okay, over the x-axis. Okay, your second transformation is going to be a vertical stretch. Okay, so you have a vertical stretch by 2 units, okay, which is this one. The third transformation is going to be that plus 6, that you know that it's going to be an horizontal shift. It's going to be left, okay, by 6 units, okay. And then last but not least, you know that it's a vertical shift by 4 up, okay. So that's for that, okay. So now what are you going to do? Well, your parent points are going to be your xy from the original equation that we had above, okay. So you know that the parent points are going to be -8, -2, -1, -1, 0, 0, 1, 1, and last but not least 8, 2, okay. So your transform points are going to be depending on the transformations that you have. The only transformation that it's affecting your x variable is going to be the plus 6, which you know that it's left 6, so it's going to be x minus 6. Now the y, it has the rest of the transformation, so you know that it's going to be 2y plus 4, okay, and those are the transformations that we have in this situation. Now I'm going to plug each of the x's here. So you have that -8 minus 6 is going to be minus 14, okay. -1 minus 6 is going to be -7, 0 minus 6, -6, 1 minus 6 is going to be -5, and last but not least, you know that 8 minus 6 is going to be +2. So I have all my x's here. Now I'm going to plug all my y's here. So you know that -2 times -2 plus 4 is going to be 8. Then you have that -1 times -2 is +2, plus 4 is 6. Then you have that 0 times -2 plus 4 is 4. Then you have that 1 times -2 plus 4 is going to be 2. And last but not least, we have -2 times +2 is -4 plus 4 is 0. Okay, so these are the points that we're going to graph. I just put a check mark here so you know that these are the ones that I want. So now I'm going to graph my points. Okay, so I have that -7 is going to be somewhere over here, and 6 is going to be 2, 2, 2 over here. Then you have that -6 is going to be here, and then the +4 is going to be over here, then -5 and 2 is here, and then last but not least we have the 2, 0, which is here. Okay, so your graph should look as something like this. Okay, do it correctly. Okay, so something like this. That is your graph for the situation. As you can see, the domain in this situation is going to be all real numbers. The range is going to be all real numbers. Okay. So now the thing that you need to be careful here is you have that the x-intercept. Well, actually we do have the x-intercept, which is 2, 0. Okay. So now what is the y-intercept? For the y-intercept, remember that you need to have you need to have your equation like this. Let me just put the y-intercept here. Okay, so the y-intercept is going to look as 0, something, meaning I need to let x be equal to 0. Okay, so what you're going to do here, you plug the x as 0, so you have y is equal to -2, the cube root of 0 plus 6, which is 6 plus 4. Okay, so that's going to be your y-intercept. So we can go back here and you're like, okay, so it's 0, comma, that thing, yes. Okay, so it's this is your y-intercept. Now the inflection point, as I was telling you back in class, what we're going to do is the inflection point. This guy is quite important. Okay, so the transform point 0, 0, which in this case is going to be the point -6, 4 is going to be your inflection point. Okay, so your inflection point is going to be -6, 4. Okay, so as you can see, this graph is a little bit different because this one, if you put your pencil, you are going down. Okay, so this one is decreasing. Okay, it's a decreasing function. Okay, over what interval is concave up? Okay, so this one I'm dropping the water here. Okay, so that one is not, that one is concave down, so from negative infinity to, and I'm going to take the x part of my inflection point always as the concavity. Remember, the concavity is always based on the x's. So from negative infinity to negative 6, this is concave down, and then you know that from negative 6 to positive infinity is going to be concave up. Okay. So for this problem, the difference is that I need to take out the common factor inside the cube root. So I would rewrite it like y equals 2, and then you have the cube root. Okay, I'm going to take out the 1/4, so you have x minus, and then you have that one is going to be what? So it's going to be at 2. Okay, and then we have the 3 here. Okay, so once I analyze it from here, I know that I have a transformation here, another one here, another one here, and here. So I have 4 transformations. Okay, so the first one is vertical stretch, okay, by 2. Then I have this one is going to be an horizontal stretch by 4. Okay, then the next one that we have over here is going to be an horizontal shift. That's going to be to the right, 2. And then the last one is going to be a vertical shift down 3. Okay, by 3 units. Okay, so after that we take the parent points of the original, so you know that it's going to be negative 8, negative 2, negative 1, negative 1, 0, 0, 1, 1, and then 8, 2. Okay, so now with the transformations, we know that the transformations that are affecting the x, and it's going to be this 4 that you have over here, so it's going to be 4x, and this one, so it's going to be plus 2. And then the y transformations are going to be 2y minus 3, and you have that situation. Okay, now we plug each one. Negative 8 times 4 plus 2, that's going to be what's going to be that? That's going to be, oh, it's too big. Okay, negative 30. Okay, so then we plug this one. Negative 1 times 4, negative 4, plus 2, negative 2. Then the 0 is going to be just 2. Then when we plug the 1, that's going to be 6. The 8 is going to be 8 times 4, that is 32, plus 2 is going to be 34. Huge. Okay, for my poor graph, that's okay. Then you have that the negative 2 times 2 is going to be what? It's going to be negative 4 minus 3 is going to be minus 7. Negative 2 times 2 is going to be negative 4. And minus 3. No, it's going to be negative 1 times 2. Negative 2 minus 3 is going to be negative 5. Then the 0 is going to be just negative 3. Then we have the 1, so it's going to be 1 times 2, 2 minus 3 is minus 1. And last but not least, we have 2 times 2, 4 minus 3 is 4. Okay, so the only ones that we can grab technically are the middle ones, as you can see. So I go and I have negative 2, negative 5. Okay, so 2, 3, 4, 5. Okay, and then I have positive 2 and negative 3. Okay, so 1, 2, 3. And 6, 2, 6. Okay, and then negative 1, something like that. Okay, so I know that my my cubic inverse is going to look like something like this, right? Something like that. Okay, so now let's analyze the domain. The domain of the situation, as you know, it's all real numbers. Okay, the range is all real numbers. what are we going to do for the x-intercept? So for the x-intercept, we don't have it there. I analyze it here. Well, it's not there. Yikes. Okay, so let me do it here. Okay, I'm going to do it on the knee. You know that the x-intercept is going to be when you have something comma 0. Okay, so meaning I'm going to let my y be equal to 0. Okay, so since we have that it's going to be 0 equals 2 cube root of 1 over 4x minus 1/2 minus 3. Okay, so I need to solve for x. Pass the 3 to the other side, I divide by 2. Okay, then I have all this equation. Okay, I need to cube both sides, and that horrible thing is a 3. Okay, so you cancel out this, so you have that is going to be 3 times 3, 9 times 3 is 27, and divided by 8, right, is going to be equal to 1 over 4x minus 1/2. Okay, so I pass the 1/2 to the other side. Let me continue here. Okay, so you know that one is going to be 4x plus 37 is going to be 31 divided by 8 equals 1/4 x. Okay, I pass the 4 to the other side, canceling out, so you know that's going to be 2. Ugly number. Okay, so you have that. Okay, so you go back and you know that it's going to be 31 divided by 2 comma 0. That's going to be your x-intercept. Okay, so quite big. Makes sense that I didn't graph it here because we don't have it yet. Now the y-intercept is going to be technically the opposite of this one. We need to let x equals to 0. Okay, if we put the 0 here in your equation over here, you know that I'm going to write it here since I'm running out of space. Okay, so you know that the x-intercept is going to be y equals 2 times the cube root of negative 1/2 minus 3. Honestly, I would leave it like that if you want to make your life easier. Okay, so I would put 0 comma, I would do 2 cube root of negative 1/2 and then the minus 3 here, close it. Okay, of course you can rationalize that. I'm just going to leave it like that since I'm already running out of space. Okay, so the inflection point, as mentioned in the previous example, you know that the inflection point is this one. Therefore, the inflection in this transformation is going to be the point 2, 3. Okay, as mentioned before, you know that the x part of the inflection point is going to be the one where the concavity changes. Okay, so moreover, we can see that this graph is increasing all the way. Okay, so this one is increasing. Over one interval is concave up. Okay, so you know that this is your inflection point. Therefore, you are holding the water here, meaning that's concave up. Okay, so from negative infinity to this point, which is 2, it's concave up. Okay, and then concave down is going to be from 2 to infinity in this case. Okay, and that's it. Okay, so in this problem, they want you to write a cube root function to describe the graph. Okay, so what we're going to do here is we're going to recall my general cube root function. Okay, so it's the general one. It should look something like this, right? Okay, so in this situation, what you have and what you can see from the graph that you have here, we are very lucky because we have the inflection point. Okay, so you can see the inflection point, and the inflection point is telling you the C and the D. Okay, I'm going to just write it there so you can remember. Then you're going to tell me, how about the B? The B in this situation, it's going to be 1, and in the situations that we're going to have, it's going to be 1. So you can just assume that the B is 1, okay, for this situation. So you have y is equal to a the cube root, and then you have that it's going to be x plus 5 inside the cube root, and then you have the plus 3 outside. Okay, so then you're going to tell me how in the world I can find my a. Well, you have another point. Okay, so you are going to plug negative 13, 9 into your y equals a cube root of x plus 5 plus 3. Okay, so what we're going to do here, I have that 9 is going to be equal to a cube root of, and this is going to be negative 13 plus 5, which is the really nice number, negative 8, yay. Okay, and then plus 3. So what's the cube root of negative 8? You know that that one is going to be negative 2. Okay, and then you have the plus 3 there, which you know that you are going to pass it to the other side. Okay, making this one a 6. Okay, so then we divide both sides by negative 2, so you know that that's going to be a is going to be negative 3. Therefore you have that your equation, it's going to look like this: y is equal to negative 3 the cube root of x plus 5 inside the cube root plus 3. And that is it for this problem. Okay, so for the next problem, what you need to do is, given the function f of x is equal to negative 2 cube root of x plus 1 plus 6, you need to find the new equation when the following transformations are applied to your function f of x. So the first transformation that we have, and since I know that I'm going to run out of space, I'm just going to bring this extra piece of paper. Okay, so the first transformation that we have here is this. I'm going to call y equals my new function. Okay, so the first transformation that we have, it's a reflection over the x-axis, so you have negative f. Okay, then a vertical compression, okay, by 1/3, so compression vertical is outside. Then horizontal translation left, so you have x plus 5. Okay, and then vertical translation down 8, it's going to be minus 8. Okay, once you have this, what you are going to do, and what I recommend you to do, is first you are going to find okay, we're going to find your f of x plus 5. Okay, so you know that f of x plus 5 is going to be equal to what? Okay, so you know that instead of x, you're going to plug x plus 5, meaning you have negative 2, you have the cube root. Then instead of the x here, you are going to plug x plus 5 plus 1, okay, and then the plus 6 is outside. Okay, so as you can see here, I'm going to combine these two like terms, having negative 2 the cube root of x plus 6, okay, plus 6. At this point, I cannot simplify more. Okay, so the next step is going to be next. Okay, so you know my steps. It's going to be actually finding your y. Okay, so you have y is equal to negative 1/3, and instead of this f of x plus 5, we're going to plug all of this chunk. So you have negative 2 the cube root of x plus 6 plus 6. Okay, close your parentheses, and then the minus 8 that you have over here. Okay, so you have the situation. Now you need to be careful, as I always tell you, you need to distribute this one here and this one over here. So what you have here, this is going to be equal to negative 1/3 times negative 2 cube root of x plus 6, so that's going to be a positive 2/3 cube root of x plus 6. And then you distribute the negative 1/3 to the positive 6, which is going to be a negative 2. And then you have the negative 8. As you can see, these two are like terms. Okay, therefore what you have here is you have that this is going to be equal to 2/3 the cube root of x plus 6. Okay, and then you have the negative 10 here, and that's it. Okay, so thus, let me conclude, and actually I can put it in my piece of paper. Y equals 2 over 3 cube root of x plus 6, okay, minus 10, and that's it for this problem. Okay, so the last problem that we have for this section is this one. Okay, given a function f of x is equal to 3 cube root of x minus 3 minus 4, you need to write a function g of x such that your g of x is equal to 1/4 f of 2 times x minus 1, and outside you have a negative 6. So again, here I would highly recommend you to first find your f of 2x minus 1. Okay, so if we want to find that one, okay, that one is going to be equal to 3, okay, the cube root of all the situation that we have over here. Let me write it down here. X minus 1, okay, close it, okay, and minus 3 is going to be here as well, okay, so minus 4. Okay, so you have that situation now. Since you can distribute this to here and here, I would have that this is going to be 3, the cube root of this is going to be 2x minus 2 minus 3. Okay, and I'm not skipping any steps so you can see what's going on there. So after that, you have that this is going to be 3, the cube root of 2x minus 5, and then outside you have a negative 4. Okay, so this is as good as it gets. Okay, so this, remember, this is f of 2 times x minus 1. Okay, now since I've run out of space, let me strategically put my piece of paper here underneath. Okay, so but I don't want that, I want my g of x. Okay, so your g of x, what are you going to do? You have that g of x is equal to this one, so it's going to be 1/4, and instead of the f 2 times x minus 1, you're going to plug all of this. Okay, so I'm going to put a parenthesis so you know the placement of my f of 2 x minus 1. Okay, so I have this equation here, okay, and then I have the minus 6. Okay, so you have this. Okay, let me just put it there so you can see everything. Now you need to be very careful because you need to distribute this 1/4 here and here. Okay, so let's be very careful with that. So you have 3 over 4 cube root of 2x minus 5, and then you distribute the 1 over 4 to the negative 4, so that one's score is negative 1. Okay, and then negative 6. So luckily here you have two like terms. Okay, so you have that this is going to be equal to 3/4 cube root of 2x minus 5. Then you have that this is going to be negative 7. Okay, so this is going to be your g of x. Okay, and that's it.